Welcome to the third lab on the course. This lab focuses on network and malware forensics. So the learning outcomes or the learning objectives at the end of the lesson, you should be able to capture network traffic using the appropriate tools and then perform protocol analysis on the captured traffic, perform malware detection, because you learn the basics, and then perform the detection, and then finally identify patterns. Malicious patterns or irregular patterns on the captured network traffic. So let's dive in with network traffic capture. For Docker network configuration, I run a command to review the network, the different networks that we have. Okay, so our major network is the secure bank network, which is the bridge network adapter configuration. And that can be found on the Docker Compose YAML file lines 72 to 74. So we also have network configuration. We have the subnet, you have the container to container configuration enabled, and then we have the host access via ports. So there are several methods in collecting or capturing network traffic. All right. We have the pre-attack baseline capture, where your network is, your device is running normally, your network is running normally. You can capture that traffic, and that becomes the baseline network traffic that you can keep aside. Then we have the building attack capture, that is while you are simulating your attack. You can also capture your network traffic so you can compare with the baseline, that's the normal traffic that capture you did. Then you have the post-attack capture, where you want to do the persistent check or the cleanup traffic. After you're done attacking, you want to see how your network behaves afterward. You want to see how your device behaves afterward. That's where we have the post-attack capture. Then we have the container-specific capture. This time around, the capture focuses on the traffic that is being generated by the containers or the machines, the containers. So those are the four major methods for capturing network traffic. So for the traffic tools or the implementation for traffic capturing tool, we have the T-Shack. Okay, the T-Shack is the command line of the command interface. Command line interface tool that we use to capture traffic. For instance, we want to capture the traffic that is being generated from with our secure bank app. So you use the command here. That's a command you use to capture the traffic, and then when you capture the traffic, you give it a name. So that's a name for the traffic, and then you store it in the directory called evidence, and then the format for the traffic is PCAP. P is for that is packet capture. Now there's a difference between packets and then traffic. When there's a single flow of there's a single flow of the network, and then what you capture comes to a packet. But where you have a flow that goes from a source to the destination, and the destination back to source, and there's a multiple flow like that, what you have is a traffic, network traffic. So but your file format, when you capture your network traffic, it is stored as PCAP. We also have recent version is PCAP engine, where you can store your traffic. Then we have another tool called so we have mentioned one. We have mentioned the T-Shack. Then the second one is the one we call the TCP dump, which is an alternative tool for capturing traffic for T-Shack. So you can run this command TCP dump to capture traffic, just like what the previous one could do. So, and then there's a third one that we call the Wireshark. Wireshark is a graphical user interface tool that we use to capture the network traffic. So, as we proceed, we'll see how that works. Now, for the capture file analysis workflow, for packet filtering, We can filter a packet by protocol. We can filter by source IP address. You can filter by destination IP address. You can filter by source port number. You can filter by the destination port number. You can filter by flag, and many more things of use in filtering the packets. Then for flow analysis, you can perform reconstruction of your network streams. We have majorly two streams. We have the TCP stream and we have the UDP stream. These are protocols. Then for payload extraction, that's what you have in number 3 now. Payload extraction, you can extract your HTTP bodies or SQL queries. And then for pattern recognition, that's the number 4 item. It helps to identify attack signatures or malicious signatures that may be available or present on the network traffic. Then also timeline curation, which helps to correlate your packets with log entries to see how to synchronize or what time the packet arrived on the capture. Okay. So let's begin with the network protocol analysis rather. So we can actually analyze your HTTP request or responses on the network, and you see a result that looks like this. Secure bank for the host, and then you see the content type, and you see the content length. So, and then when HTTP response, we're going to have this response. Once you have this response, and you have the response of 200, it means that web page is doing well. All right. Then for SQL injection pattern in traffic, of course, this is the common pattern that we use for classic SQL injection attack. You can find that on that attack, the CH script line 27, you find that username admin or 1=1 password, not anything. Okay, can go. Then pattern 2, where we have a union-based SQL injection, which a potential will be using to subvert the payload that we use. And then pattern 3 is error-based SQL injection, and that's the payload that we use to perform that injection. Then you can, if you want to look at data injection detection, you want to detect data injection on the packet captured, that will be the header of what you should see. And then another variant is the second one that begins with get. Then the response of the output command will have things like processing count 1, and then you have whatever thing you need to initiate. For the cross-site scripting payload identification, this cross-site scripting has to do with issuing script to your web page through the URL or through the web browser. So, and typically it will look like what you see here. We have this. That's for reflected cross-site scripting. We have stored scripting, which uses the command listed here. Then going further with the I've talked about reflected. I've talked about stored. Okay, and then we have the DOM-based cross-site indicators. So let's begin with what you have on the scripts. Let's go to the lab and then run some experiments. So the first thing we need to do is go to the Docker environment and then power it. Start the Docker environment using that command. That is, if the Docker environment is not already running. But in that case, from the previous lab, we should have it running, still running. If not, just run that. And then the next thing is to verify the network we're using. So okay, let's see if this. Let's examine our Kali first. Then we'll come back. Okay, we are still here, so everything is fine. So let's check the network list by running this command. Network list. Copy and paste clipboard. Okay, so it lists development network, and the network of interest is the secure server fortress secure bank network. That's our network of interest. Let's go back to the script. Okay, yeah, there's it. So we can expect it if you want. We did this in lab, so just copy this and dump on the Kali, and it's going to inspect that network for us. So we've done that already in lab, but you can try that. And then so begin something serious. First of all, begin to do network traffic capture. All right. In step one, we do pre-attack baseline capture. That's the normal. I want to capture the normal state of the network without attack. Okay, this is important for us. You need to know how your network behaves when there is no attack, so that if there's any variation going forward, you can suspect that something is happening to your network. All right. So that is the essence of pre-attack baseline capture. So to do that, first you have to enter the Kali tools container by running this. So let's go to Kali. I've copied. Go to Kali. Yeah, that's done. So let's go back to scripts and then capture all traffic on it is 0. That's the internet port internet interface we're going to use, and save the evidence. Okay, and save to evidence, the evidence further. So just run this. That means we are using T-Shack here. All right. T-Shack is the tool we're using, and the interface is it is 0, and then the host is secure bank, which can be replaced by the IP address, and then the location for saving is evidence, and then the name of the file one captured is network capture. So that is what this command is saying. So let's copy here and then go over here, and then let's dump it here. And then start. Okay. And then run it. So it's running as a user. The user is root. So it's trying to capture traffic on it is 0. So now this is similar to you launching your Wireshark. To the Wireshark, just go to application here, enter Wireshark. Wireshark. So this is Wireshark. You launch it, and then you set the interface, and it needs to capture the traffic for you. So in step 2, this time around, you're going to capture the traffic during attack. So capture specific application ports, Flask application and MySQL. So Flask application runs on port 5000, and then MySQL runs on port 3306. So when you issue this command, it's going to capture traffic that happens when there is attack. So, and then you need to store the traffic, the captured traffic in the app _ traffic.pcap. So you can copy this and then go to your Kali. Instead of this, okay, you can disable if you want. You can stop this capture, or you open a new tab to capture. So to stop this, Control-C stops it, and then I paste the new one. So this time around, when there is an attack, it's going to capture the traffic for you. All right. So let's go back to the scripts. The alternative to, like I said, to using T-Shack is using TCP dump. So you can decide to run this other command instead of this one. All right, instead of the one in step 2. Sorry, instead of this other command, you can use, instead of this other command, using T-Shack, you can use TCP dump. Then in step 3, you're going to run that script in a separate terminal. So in a separate terminal, we're going to run the scripts. So what we do is go to Kali, open a new terminal, and then paste what you have in the clipboard, and then launch that. Was that something went wrong? Let's see what you have there. Okay, let's launch setup first and see. Yeah, let's enable the machines, start the machines. That is the containers. Let's wait for this to happen. Okay, so you have to move into the script folder to launch that attack SQL. So let's look for that command. Yes, this. No, exit, not this. Yes, this command. So at this point, you can attack. Launch the attack scripts. All right. So it's firing attack as we speak. So let's go back to the scripts and see what happens. So while we fire that attack, we're supposed to be running this. So okay, did we stop it? Let's check if I did. All right, now. So it's now what is happening is that while I'm launching attack here, this command is already capturing packets. The packets that involve port 5000 and port 3306 have been captured. So you can repeat the attack launching again and see what happens. So let that continue. So once that concludes, then we are done with step one. We'll move down to critical analysis. So let's say if it is done, okay, it's done. So that's all right. So let's see critical analysis. Before we go to critical analysis, okay, let's just look at the steps first so that we don't run too fast. Yeah, so for critical analysis, we are going to do HTTP traffic and HTTP attack traffic analysis. Step one is to do SQL injection via posts. So manually, we're going to send SQL injection payload using this command and this command. All right. And then the second step, we're launching up this too. So let's try this command. Our capture should still be on. We said okay, still on. So let's come here and dump this. So it's going to ask us for the next item, which is this manual SQL injection we're doing, not automated. That copying wasn't done, so that's why it's having that problem. Let's repeat the copying process. Copy again, then go back to Kali, and then let's press. All right. Yeah, so the payload has launched itself to the application and it has opened welcome admin. This is what we see on the landing page of the application. So let's see what the script is saying next. So we've done with step one. Then step two, we're going to perform. Now in step one, we did SQL injection via post. In step two, you're going to do a command injection via get. So you run any of these commands to a secret. Then in step 3, you're going to do cross-site scripting payload launching. So you launch with this command or with this other command. This is a URL encoded version of it, so you can do that. And then so that we can perform pickup analysis. We can perform pickup analysis. So in pickup analysis, there are several steps listed here. One is to filter escalation traffic using this command and this and this. So this is for T-Shack. We're using T-Shack actually. So just copy this. Let's just copy all of them at once and then down. Kali, right click, paste clipboard, and then it says this could be dangerous. Of course, we are doing a dangerous, but it's a controlled environment, so nothing harmful, nothing dangerous. But if this were on a live system or a system that you don't have authorization to use, then it becomes illegal because hacking is illegal. So that is for T-Shack. But for Wireshark, like I said, Wireshark is user interface generated. So what you can do is, you want to use Wireshark, let's say for the packet, you can just type Wireshark here if you want. If you don't want to go through that process, just type Wireshark here. Wireshark, and then what's that? Was it? Okay, let's take a new. Let's try again. Wireshark. Yes, so it's gonna come up. Yes, so and then it's asking us to select the right interface. Our interface is we're using it is 0. You can see the movements here. It's showing that the traffic is seeing something. So just double click, and then let's maximize this, and then you see traffic dropping. It's dropping. Yeah, concentrations are dropping. So if you go ahead and launch attacks like we did before, where is the script? Where is it? Yeah. For instance, the task that we run, like this T-Shack. No, let's see. Yeah, the task script that we run. So as this attack script is being launched, you can see what is happening on Wireshark. Wireshark is collecting movements or traffic of what is happening between those 2 ports that we talked about. What were the 2 ports? Let's see that again. What were the 2 ports that we're focusing on? Yes, port 5000 and port this 3006. So that is what Wireshark is doing for us, capturing traffic. So you can use Wireshark to reconstruct TCP streams, or you use T-Shack to do that. See Wireshark, right click on the packet, follow, and TCP stream. So let's say we are done capturing. Let's say just come here and stop packet capturing. So these are our packets. So let's just right click on one. Let's say I right click on this one, and then follow, and then take the TCP stream. So this hasn't shown us anything useful. So you can try that for other packets, and then to review, depending on the length of the attack that has been conducted, that you've launched. So that is what Wireshark can help you do. There are many more things that Wireshark can help you to do, majorly for traffic analysis. So you do your traffic analysis to see when there's an attack on the network or when not, or when there's a network failure or whatever problem you have on the network. And other things, even credentials can be reviewed. Even if a user visits a website that is not encrypted, okay, of course, you can use Wireshark to review the login credentials. It can go for you. Then in step 3, you have to extract HTTP payloads using the command. That is, we're still working with C# and then using this command. Then step 4 is to perform log analysis integration using Elasticstack. Okay, so in step 1 is to view the stack, to view the logs rather, and what you need to do is if you're still in this script directory, you change directory, step backward, and then move into evidence and look for secure bank.log. We did this in the previous lab. We were able to see 9 log files in this folder, and one of the files happens to be secure bank.log. So you might want to check that out and see how that happens again. So go to this, and then you say if you're here, just step back a little, and then let's check. So this evidence is going to be okay. This is a wrong place to check that. So let's say where should we be? Let's open your tab, and then ls. Okay, so you see evidence there. So cd evidence ls. So you find that cd packets, all of that. So now the file you're looking for is the secure bank.log. So you can use a cat to view what is in there. Cards, secure bank log, and then you can see the log. The log is captured here, and then that can help us to do our analysis. That is what it's supposed to do in step 4. Sorry, in step 1. Yes. So in step 2, we did this already. Is to find patterns. Okay, for login attempts, field attempts, account attempts. We did this in the previous lab, so don't need for me to repeat that. Then in step 3 is to access Kibana using this address, which we also did in the lab, in the previous lab. We were able to open this on the web browser, and then we went in there. So then what we need to do is, once we have gotten into Kibana, because Kibana is used for visualization. So what we need to do is to search for patterns. For instance, you can run this command to say, we can just drop this command to say what happens to search for the SQL injection on that log, okay, on the filter. And then step 4 is to correlate the network with timestamps. By run this, just copy this to your terminal, and then you dump it, and then it's going to work for you. And then you can compare your log entries by running this command. Now, this is a timestamp, so you can change this time to any time to filter. You want to see if in the existing log, that is in secure bank.log, there is an entry that corresponds with that timestamp. That's what it's saying. So it's funny this, but like I said, you use grep to find patterns in a file. In step 5, which is attack pattern recognition, you want to find out from that log if you have if your system is able to detect the first attack. So you just copy this and then run on your terminal. It will look for log entries with login field. And then for SQL injection pattern counting, you run this command, grep this, or you grep select. Then for command injection detection, you use this other command. Just copy this. All of these commands are working. Just copy to terminal, and then they work fine for you. For detection rules, using Suricata or Kibana. Now, we are not using Suricata, so we're using Kibana. So So you can actually find out whether the attacks that were launched on the network, on the device or the network, whether it was escalation attack, whatever kind of attack you were using, is going to work for you. So whether you're using Suricata or you're using Kibana in that case, the steps I've listed here are going to work. So that's it. So we try to run out the steps. We just copy them to command prompt. So the ones I have to go to the browser, copy them to the browser, and see how they work for you. And then give us the report. All right, so let's look at what you have more on the slide so we can conclude the lab. So yes, for log analysis integration, which I just talked about the steps on the documents. So for explanation, one of the things you need to do is log stash passing configuration, which is given to us here. This is a script that you're not going to. It's just a snippet actually, so it's not gonna. Don't have to run it like that. But the commands I've listed on the scripts happy to provide connection to the log stash and the assessment you need to do. So the log pattern you're going to be seeing, like log pattern matching results you're going to be seeing when those scripts are run, is what I've listed here. For instance, let me get my pen. So the first entry here shows the timestamp, and then for the pattern called login attempt, and then the username called admin, password called sorry, there's no password listed. So admin or 1 = 1 is this they are the same pattern that we use to launch escalation. Then the IP address is also given, so that could be an entry you're going to find in your log. And then you're also going to have to find something like the timestamp, the log level, the log message, the IP address, the username, and the IP address could be part of the things you're going to see in the log when you perform the analysis. And then for correlation of network traffic. Okay, so we have for network capture, we're going to have the timestamp, and then you're going to have the payload type, and then you're going to have the method, either post or get for that endpoint. Then for log application number 2, you have the timestamp, and then you have the pattern. Okay, that's login attempts, for instance. And then for network capture, that's number 3. We're going to have a timestamp again, and then the response, the HTTP response. The application log again, you have the pattern and then the timestamp. So you match your traffic with the patterns you're trying to establish in your investigation. Furthermore, for correlation findings, you have the log entries. You have to confirm whether there's an attack success or attack failure, depending on the pattern you use your graph to find. And so the network traffic provides the raw payload details that you can analyze and then find out what actually happened to your network. For time reconstruction, okay, so you have the timeline listed for you, you have the patterns of the payload they're trying to establish. You see attack, when the attack starts, you see the timeline, you see what injection was implemented, you see the pattern, login attempts, either failed or successful, you see the account view, you see the attack pattern and the rest. Those are the things you see in the log as you analyze them. Then looking at attack pattern recognition. Okay, for SQL injection, that is for tautology-based escalation, you have something like admin or 1 = 1, or you have admin equals admin or 1 x equals x. That forms the what we call the tautology-based escalation. Then for the union-based escalation, we have the union sets no username password. And then for error-based injection indicators, it could be database error messages that can be seen. The messages will come from HTTP responses. Then we have the trap traces revealing the structure of the database. So, and then for command injection attempts, you have who am I, or IT, or ls -LA. That is for direct command execution. Then, but for change commands, we have the use of cats to access what is stored in the HTC password file. Can you also have the ampersand controlling process command, or use the uname. And then for some share execution, one can use the who am I or the ID to check. Then for cluster scripting, we have the basic cluster scripting. For that is based on the last method. We have the cookie stealing using this other payload. We have the DOM based using this payload. Then we have the coded payloads using this payload to launch the attack. For brute force indicators, how do we know whether a brute force attack or not has been conducted on the network or has been attempted on the network? When there's one we call the rate-based indicators. When you find multiple login attempts within a very short time window, then brute force attack has been attempted. When you see sequential username or password combinations repeatedly, they can also suspect that brute force attack is being attempted. Or you have failed login clustering. That is another indicator of brute force attack. Therefore, pattern-based indicators, when you find a log that looks like you have this timestamp, admin failed, username, with all failures repeatedly, could I suspect that somebody is trying something, guessing passwords, for instance, and trying to see what matches with what is the database to get access to. So you find common brute force patterns like admin for username, admin for password, yes, admin for username and password for password, or admin for username, we have 1, 2, 3, 4, 5, 6 for password. So when you see such guesses, you can suspect that one is trying the brute force attack technique. Then we have the time indicators. When you have consistent time intervals between attempts, repeated maybe every 5 seconds, or every 5 minutes, one is making an attempt to log them. You can suspect that one is guessing something. One is trying the brute force pattern. Or you have automated timing patterns. It's just 1 hour interval, for instance, or 1 second interval, for instance. You can suspect heavily that brute force is being attempted. So, with a command that I showed you, either using Wireshark or using TCP dump or using T-Shark. So you're going to be having your capture stored. For instance, you may have full capture. Of course, these are just file names. You might choose your own file name. Okay, so you have, like, for instance, you have a full capture, pickup, you have SQL, injection pickup, you have command injection pickup, you have custom scripting, traffic pickup. So file names, depending on what type of attack is performed, why the capture is being done. So if the capture is being done during cluster scripting attempts, then you can decide to save your capture, your packets with the name that suggests the pattern at that time. Okay, and then you're going to have key artifacts extracted from your payloads. For instance, in an experiment, if you had waited, would have seen over 150 HTTP requests with attack payloads, and then number of SQL injection attempts, number of command injection attempts attempted, and the number of cluster scripting, sign-ins, and command and control. The C2 is command and control communication. For attack patterns identified, depending on what has been launched. One is SQL injection. We have talked about tautology, I've talked about union, I've talked about error-based. The second one is command injection, and there are variants of them: semicolon-based, pipe-based, we have logic operator-based, and the rest of them. For cluster scripting, we have reflected, we have stored, you have dump based. And then we also have the reconnaissance patterns where we have post scanning, service elimination, directory brute forcing attempts. For protocol level weaknesses, which could be discovered in your analysis. So you could have HTTP protocol issues that can be seen in the traffic that is captured. You could have application protocol weakness also seen in the traffic. These are some of the things you see when you sit down to analyze the traffic that TCP dump or T-Shark or Wireshark they have given to you. Find things like SQL queries transmitted in clear text. You find no impute validation at protocol level. You can also find logging protocol gaps like incomplete cross-site scripting attempts logging or no database query logging. These are some of the things you find in the packet. So, of course, like I said, in Lab3, but one key thing you will need to do while performing your ethical hacking or your forensics analysis is reporting. So in your report, you're supposed to make recommendations. Every ethical hacker or every forensics analyst makes reports, makes recommendations. So the recommendations can be based on what has been discovered, and can also be based on the vulnerabilities that are found on the system or the network or the software. For instance, if it is network-based detection that has been carried out using the cutter. So what you see here is an example of a rule, okay, that can be configured on that intrusion detection system. Right? Then for command injection detection, this can be the rule. Allow TCP in to secure your network so that when you have your network, your intrusion detection system here that has the right rules, it will be able to detect and flag when there is an intrusion attempted. For crystal detection, that's the rule that can be configured to do the job for you. For forensic detection enhancements, you have the rule there to configure real-time monitoring. You can implement packet capture on all container interfaces. You can deploy network intrusion detection systems. You can also set up real-time alerting for attack patterns or create automated pickup analysis pipeline. So in that case, as your pickup is as your traffic is being captured, it can also do automatic analysis for you and report it to give you situation reports of what is being seen by your network. And then for your detection recommendations, one of the things we suggest is protocol hardening, where you have to implement the HTTPS with proper certificate management. Okay, we don't. It is not a good practice to allow self-signed certificates, and then you can also add web application firewall rules, like the ones we just listed. Those ones we listed for intrusion detection systems can also be configured for web application firewalls. And then enable HTTP security here, that is very important. Implement rate limiter and network layer. So if a particular IP address is found trying to connect to a network severally, presumably maybe the same pattern or time interval or rate, then one can suspect your network intrusion detection system can block an IP address based on some of these patterns that are being seen on the network through your traffic capture and analysis. So that brings us to the end of this lab. We look forward to having the next lab. Thank you.